In this video, we are going to derive a wonderful relation between focal length and then radius of curvature. And before that, you should clear what is small f and what is capital R. Sir, in a concave or convex mirror, the center of the spherical mirror is called center of curvature, and then center or middle point of the concave or convex mirror is called the poles. The line joining the center of curvature and then pole is called principal axis. Sir, all the emergent rays, that is all the reflector lights are meeting at the point is called principal focus, capital F. The distance between the center of curvature and then center of the mirror, that is pole, is called capital R, radius of curvature. The distance between the principal focus and then pole is called focal length, small f. Now, we are going to derive the relation between small f and then capital R. The distance between the focal point and the pole, and the distance between center of curvature and then pole. Very important relation and also important question. Okay, let me discuss. And before that, let me consider a concave mirror. The center point of the spherical mirror is called center of curvature, and the middle point of the spherical mirror, that is a concave mirror, is called pole. It is connected by the principal axis. Am I right? Right. Okay, now I am going to pass the incident ray parallel to the principal axis, like here. The incident ray is impinged on the reflecting surface at the point of M. At the point of M, it reflected and passes through the point of principal focus, capital F. Okay, students. Now the condition should be arrived at. The distance between the focal point and then pole, it's called the focal length. The distance between the center of curvature and the pole is called radius of curvature. Okay. Students, listen here. This is the incident ray. This one is reflected ray. We know very well the angle of incidence is equivalent to angle of reflection. And before that, we should draw the normal line. So, the normal line like this. Am I right? So, the angle of incidence I equal to angle of incidence R. According to the laws of reflection, I is equal to R. So, I am going to write it as here R is equal to I. The portion of MFP also creates an angle of deviation, so it creates a value of 2I. Am I right? At the same time, angle of MCP creates an angle of incident angle. How much of incident angle is created to the mirror is equivalent to the center of curvature creates angle I. So here, two right angle triangles are created. One is MFP. Now I am going to draw the imaginary line to the perpendicular of the parallel axis from the point of M. Okay? This is the triangle of MFP. And then one more triangle is MCP. Now comparing these two right angle triangles, we can easily derive the relation between focal length and the radius of curvature. Sir, the angle of the triangle of MCP has the distance of radius of curvature R, and the angle of MFP has the distance of focal length F. Am I right? By comparing these two triangles, we will get easily the relation between F and R. Okay, come on. The angle of MCP equal to I. The angle of MFP equal to 2 times of incident ray 2i. Now I am going to compare these two triangles. The triangle of MCP and then one more is angle of the triangle of MFP. Now let me discuss the values of MCP and then MFP. By solving in a trigonometry manner, let me take the tan component, tan of I, that is the right angle triangle, tan of I is equal to tan theta is equal to opposite side by adjacent side. So opposite side is PM, adjacent side is PC. Okay students, PC. And then here the triangle of MFP, also I am going to find the value of tan theta. So tan of 2i equal to opposite side divided by adjacent side. What is the value of opposite side? Here is the angle, so 2i, opposite angle is PM divided by adjacent side is PF. Am I right? Now I found the value of tan I and then tan 2i. Sir, I is equivalent to tan I is equivalent to I because tan of I is too less. So let me consider as tan I is equal to I. Eventually, tan of 2i also consider as 2i. So now I am going to write it as I is equal to PM by PC. Here 2i can be written as PM by PF. Okay? Right. Now I am going to substitute the value of incident angle I in equation number 2. So now I am going to consider this is the equation number 1 and this is equation number 2. Substitute the value of I in second equation. So 2 times of PM by PC equal to PM by PF. Am I right? I substituted in the value of I in second equation. 2 times of PM by PC is equal to PM by PF. By simplifying this equation, PM will be cancelled. So 2 times of 1 by PC is equal to 1 by PF. By simplifying this equation, 2 times of PF is equal to PC. What is the value of PF and then PC? PF is equivalent to the distance between the focal length and the principal focus is focal length F. The distance between pole and then center of curvature is capital R. So in terms of PF, I am going to substitute the value of small f. So 2 times of f is equal to, what is the value of PC? Capital R. Finally, we derive the relation between R and F. Otherwise, the focal length F is equal to R by 2. This is the general relation of F and R, focal length and then radius of curvature. If you find the focal length, you will easily find out the radius of curvature. By 2, the radius of curvature by 2 is equivalent to focal length. Very important 3-mark question, students. Study one.